Ok.
Vado a vedere gli altri.
Thank you. Okay, sorry for the inconvenience. We can start now session 5B, Iowa, co-located with COA workshop. The first presenter is Iowa, as you know, is a workshop aimed at presenting innovative web app according to the modern requirements for of app available on the web, so that they have to be possibly scalable and respond to the user in a straightforward and appropriate way. We got 4 papers this year. The first author is Rui Jose. The title of this presentation is Automated Generation of Web Resources for the Locative Web. Okay. Do you put the presentation on the desktop?
Yes, I'm not sure desktop. Using the one.
Okay. Locative Web. Okay. Sorry, I missed the mistake. Yes, I will share. I will share the screen. First, I have to open. Share the screen. Window. Okay. Share. Okay. Do we have a slide? Okay, you have already? So.
I have it just now. Okay, let's go.
Okay.
Okay, so everyone watches now with someone who's not wanting to see me, but just a second one. That's fine. You are all here, so thank you very much for your time and for waiting. My talk is about the locative media and automated generation of web resources for the locative web. So I guess I'll just be here. Okay, so we all have lots of applications in our mobile phones which are essentially somehow located. They help us to park our cars, find the bicycle parking, find the public transportation, go to a festival. So they all have in common that they were created for one very specific purpose. You also have some applications that people use for the same purpose. For example, Facebook, it's very used for events. Instagram also, although it's terrible for that. I hate it when my students do it. Yeah, to try to scroll through images to get information, which is very weird, but I love it. And of course, Google Maps, where you can find everything, for example, in Istanbul. So what's common between these ones is that they all have these, they were very well designed for one specific purpose. So they offer a very good experience to people who use them because they are created for that one specific purpose. These ones, not so much, but they have the power of being widely used for many purposes. and therefore they're not very good at anything specific, but they have this ability that you always have them for something. So why is this a problem that currently most location-based services actually delivered as custom-mobile applications? The thing is that each application is actually one specific package where you put the specific data for that application, the context, the user experience, the interface, everything is carefully crafted for that one specific experience that you want to experience. So that is very good from a user perspective. It offers a good experience. Normally, there's also a problem. Sometimes they are very cheap applications, so not that good. But this coupling is good because it helps you to adjust to these specific purposes. But at the same time, it creates a fundamental limitation in terms of what should be the global deployment of locative services. So why is that? First of all, it does not scale for service creators. If you want to create an application for your visitors, for your store, for whatever, you can't be creating a very good application because they are very expensive. And unless it's a very good application, people will not like it because now they have the good experience of the good applications. And so anything below that fails to meet user expectations in terms of what they are already used to see. Secondly, it doesn't scale for users. So, I mean, they are very nice applications, but most time people do not even install them because they will need it just for one very specific purpose, which is a very transient situation. They would not even know the application exists, and in the end, they can't install all the applications they could possibly need for their daily life. So it doesn't scale for users either. It's good to have all these application offers, these huge stores, lots of applications, but you'd never get an application for something that is very specific, unless for some reason you really find it very, very useful for that particular time. And finally, it promotes this extreme conceptual, technical, and administrative fragmentation where each application is its own silo in terms of its data, its features, the way it's designed, those things. This is also better for users because all the applications are different in some way, but it's especially bad in terms of key properties of digital innovation, which we know to be convergence, generativity, and the ability, of course, to connect these systems to each other. So in the end, what's happening is that we are missing the opportunity to deploy lots of locative services that could be useful. So there are many entities who have the data. It's of location-based data repositories, lots of data that could be used, lots of things that many entities would like to make available to their potential customers, but they do not have the tools to make it in an efficient way. There's no user-friendly method, there's no efficient way to do it. So this becomes a major missed opportunity and a massive waste of value for both for those who use the applications and, of course, those who have the applications to engage their customers, and of course, those who could benefit from these applications in the right situation. Of course, the web would be the obvious answer to these problems. It has usually been. And so it's a fascinating technology. You have these small core principles, but we already know that they are actually very good at offering us all these nice things in terms of openness, interoperability, wide access, and so on. And there was an
Please, can you close the microphone, please?
This paper from 2008. So it explored this idea that you could add some metadata to web pages, coordinates, location names. And there's been similar attempts also in other worlds, but this has not worked so far. There's never been enough to actually provide us with an efficient way to create locative applications. So web technologies have reshaped many domains, but locative services remain an exception, and so it remains out of reach to use web for this, to replace all these applications that we nowadays have. So what we did with this work is we're trying to embrace this vision that there should be a better way, and that locative services should indeed aspire to the same principles of universality and openness that have made the web such an incredible success. So we are exploring this new locative web paradigm. Large scale of locative web content, but publishers, which is also important what we're also talking about. And so the idea is that we have this notion of locative resource, which is not really a web page; it's actually structured data. And it's meant to be data-centric because it's produced directly from data. It's web-based because it is a web object. And it's designed to represent only the information, the services, whatever you want to package for one specific situation. This offers a low entry barrier because they can be generating large numbers from data, and because they are generated automatically, they can also be generated for this specific situation. Because you control the whole process, and it becomes much easier to have the scalability to produce these very specific resources for very specific situations. You have openness because anyone could be able to do this, and then you can also have interoperability because you will be able to connect these resources between each other. Right? So they would form a graph, let's say, not necessarily a web in itself, but a graph of data. So they will have these two representations. The structured data could be accessed directly by organizations and applications, and the web representation will allow people to access these in the situations they need. So there will always be a web representation, even if the other one can be used by applications and services. And by being web, it means that you can use your browser. It's also designed for humans. It means that we have to package the right data in that context. It's not like a data graph where data is normalized and you're always jumping from one node to the other. Now we have to make this right package with the right data for that particular context, and you have to bring data from any places if necessary. So in terms of this research, what we want to do is to understand essentially this process of data generation and how it could work with all these many entities being able to use their own data sets, to use their own located resources. And so we started by defining this structure of a located resource. This is it's one of the iterations.
3 minutes, eh?
It's one of the iterations we have where we structure this to have all the things that we need. So there's the structured data, there's the relationship to all resources, and the resource level, which always works as a common representation of resource, so it's always understandable, which does not necessarily happen with master data entity, which has schemas, or you have to understand schemas. So we develop also a locative site toolkit to generate these large scales and be able to experiment with this. We did these case studies to be able to try this approach with very different types of data, very different structures in terms of data as well. So they are all very diverse in all these things. We developed this data processing model to transform the data into representations and then into the HTML representations. So the HTML representation is created only from the XML representation to avoid further dependencies, which is what we're trying to do. So as you can see, the data itself can become custom-wide components, and it can also become part of the header, so that this part of this representation can be used by users, but also by other pages. Okay, so some of the final challenges we found is that the interface is challenging. Of course, you have to make a generic interface for our web. We have to map to multiple data schemes, so we found a strategy using web components which are mapped to specific schemes. In terms of openness versus convergence, we had to address the challenge of combining openness, which is interesting because we want to have the system to be extended easily, but at the same time we need to promote convergence because otherwise we will lose the ability to scale. So it's always a gamble that you have to do, and we did that with these 4 strategies or guidelines to dealing with heterogeneity, where we try to absorb the different impacts of heterogeneity and be able to bring this into this notion of convergence that we need to have. So to conclude, we are exploring located web resources as a novel concept. We have an early implementation. We developed 4 case studies. We're dealing with these challenges of making it scalable. Um, we identified 4 general guidelines to mitigate the consequences of heterogeneity. Um, but in the end, what we're trying to achieve is that once you define these assumptions about data, then we are able to have all the model, the work on the models, and from there create all these locative sites and connect them to each other. Thank you very much.
Thank you. Are there any questions? Very quick question. Okay. Thank you so much. Sorry. So now the floor is to the next presenter. I need, where is? Uh, Um, Son Ngok, Vu Tui Diep, Pan Dui Hung. The title is B2B Service for Tracking User Behavior. Is a virtual user, so I stop my sharing. Can you please share your screen?
Okay.
Okay. Good. We see properly. Please, the floor is yours.
Okay. Hello, everyone. Today I will represent our research titled B2B Service for Checking User Behavior. Let's begin by exploring the problem and motivation behind this work. Okay. Problem and motivation. In the era of digital transformation and industry uh, 4.0, B2B models are growing rapidly. Businesses are investing heavily in digital marketing using SEO, online advertising, and personalized content to engage customers. At the same time, SaaS platforms are helping companies manage data, automate workflows, and analyze user behavior. However, despite this trend, many businesses still face challenges in collecting and using user interaction data effectively. So, how we can offer a simple yet powerful solution for checking user behavior in B2B context? Okay, let's take a look. Our solution is a simple but scalable system designed for ease of integration. It allows business or business partner to collect user behavior data using JavaScript and transmit that data to service provider for storage and analyze. The object is to make the system a simple system to help business collect data, easy to develop with business provider, easy to deploy to business partner, simple and easy to understand data. Now let's see how the system is structured. Okay, this our system architecture. This diagram gives an overview of our system architecture. There are two main actors: the business partner who embed the data collection script, and the service provider who process and store the data. User mouse activity is captured via JavaScript sent to the backend using Socket.io and then stream using Kafka to Spark and store in HDFS. Next, we will take a closer look at the role of each actor, starting with the business partner. This is the architecture of business partner. When a user interact with the business partner website, a script capture mouse movement and send that data in real time via socket.io. The web server then encrypt and package the data according to API standard and securely transmit it to the service provider over HTTPS or in the internet. Now look at what happened at the service provider slide. This architecture of service provider at the service provider side, data is streamed into Apache Kafka, passed into Spark Streaming for processing, and finally stored in HDFS. Processes data can be used for visualization or sent back to the business partner. We have seen how the architecture. Let, let's dive into the detailed system design. Okay, the system design, uh, we break down step by step for our system with process one collecting data using script and sending collected data into socket channel. Process 2 is Kafka producer configuration, and next is extracting data on socket channel and using producer to send data. And the process 4 is initialize consumer and read data from Kafka using Spark to data frame. Uh, Process 5 is pre-processing data, and the last is write press data frame to HDFS. Okay, now let's see how this was implemented and tested. We implement a simulated e-commerce website using Flask. The front end include JavaScript for capturing mouse activity, and the back end include functionality for sending data to the service provider. During simulation, mouse movement was recorded and streamed through our processing pipeline. As we can see, every mouse click coordinate mouse path are shown in given result image. This allows the service provider to observe real-time user interaction data. Okay, now the summary. In, in conclusion, we propose a B2B service model for collecting user behavior data. It's lightweight, scalable, and easy to deploy, even for partner with minimal technical adjustment. Service providers can also customize the system for different use case by adjusting parameters and looking ahead. There are several directions to expand this work. In the future, we plan to extend the system to cover more complex data collection scenario, ensure compliance with data privacy laws, and improve the system performance for large-scale deployment. That brings us to the end of our presentation. Thank you.
Thank you. Are there questions from the audience? I have one, one question. How did you succeed maintaining the privacy of the user with such an infrastructure? It seems to me that you collect a lot of information from the user point of view. How do you manage the privacy? Are you anonymizing data? How do you?
Uh, okay, I see the privacy law in per user Uh, okay. In the paper, sorry. Okay. In our paper, well, we had introduced about the privacy law with personal data, and we need to use some relevant law and regulation like GDPR in Europe or CCPA, CPRA in California, and we have write it in the paper.
Okay. Okay, thank you. So now the time. Um, sorry. Um, it's time for Stelios Koutsavelas and Ioannis Zorakidis contribution to nosocomial infections detection via biosensor particle spatial simulation in mixed reality environment. Please, Stelios.
Thank you very much,
Um,
Mr. Chairman. Uh,
just a second. Okay. Can you share the screen,
yes.
please?
Uh,
I stop camera because I try to make the audio more audible here.
yes.
Okay. I see. Please. We don't see the screen. Okay.
It's okay
No.
now?
No.
No?
No. We see a wrong window. Are
Yes,
you
yes,
sharing
yes,
the
yes,
window?
yes.
Okay. Okay. Okay.
Yes,
Okay.
yes.
Okay. We see the full screen. Okay.
Sorry.
So you can start the presentation.
It's okay
Okay.
now?
Good. 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 Yes.
Thank
Perfect.
you.
Thank you.
Thank you, Mr. Chairman. Hello to everybody from Greece. I'm Stelios Kouzeleas from International Hellenic University in Greece.
Please use a high voice because here we do not have an audio repeater. So
So,
speak loud as possible, as much as possible.
louder? Louder.
Yeah. That's
I'm,
fine.
I'm gonna try.
Okay, thank you.
Thank you. So, contribution to nosocomial infection detection via biosensors particle spatial simulation in mixed reality environment. So, what is about? It's about a description of a theoretical frame, for instance, of a real-time digital multi-system simulation of nosocomial infection in mixed reality environment. So the aim is to involve interdisciplinary scientific areas to describe this theoretical frame. The objective is to describe the description of all the technical conditions and requirements of this simulation system in order to contribute to a future implementation in real of a real-time 3D spatial detection, quantification, simulation with future data monitoring and nosocomial bacterial rates. The methods are 3D simulation in AR environment based on voxel and on point cloud technology, with a potential comparison and evaluation with ideal rates in a comprehensible way. And the result is a simulation multi-system that allows both healthcare specialists and political decision makers, and why not the users of the clinical environments, to evaluate a hospital environment sanitary by taking suitable measures. So some words for the introduction. The infectious diseases is a very serious healthcare problem today, as they are responsible for about the 15% of all deaths worldwide, and we expect 10 millions by 2050. The nosocomial infection affect between 5 and 20% of hospital patients, increasing the cost by billions due to the hospital stays, higher medical expenses, and of course the bacterial resistance to the medicine with traditional methods. So this will be leading almost 30 million people globally into extreme poverty. On the other hand, the traditional diagnostics methods have many limitations due mainly to the time-consuming laboratory procedures, and even the new techniques present other limitations such as reliability, sensitivity, efficiency, etc. So we can use some sensors called biosensors because they record biological parameters, which is present a realizable way to traditional methods for detecting bacterial infections in clinical environments. However, all the present existing models, which are dynamic, complex, and hybrid simulation models, are based mainly on 2D diagrams, 2D line charts, and 2D spatial distribution results. So there is a need, the need is significant of the existence of an effective and comprehensive bacterial infection simulation that we propose with spatial simulation techniques in 3D mixed reality and no linear diagrams, with biosensors technology and 3D voxel simulation systems. So the main objectives is to detect and manage the nosocomial infection particles inside a hospital environment. The second one is to represent the nosocomial infections particles in 3D VR spatial simulation and in 3D volumetric point cloud voxel simulation in AR environment also, and to contribute to a wireless biosensors grid system creation adapted for these infection particles, and of course, finally, to describe the theoretical description of an adapted methodology of 2D, 3D effective spatial modeling for various simulation environments with this presentation system. So some innovation points is simultaneous 3D spatial structure modeling with nosocomial infections particles in immersive VR and AR environment, because almost all studies simulate today in 2D and 3D linear diagrams or 2D spatial formats. So a method to obtain accurate measurements by improving and connection biosensor systems, a volumetric building modeling technology, provide to user the ability to real-time immersive experience in AR, VR, a significant contribution to health experts or political decision makers or even the users for better understanding the nosocomial infection behavior and deliberating over the same platform. And of course, a pedagogical approach ensure the immersive pedagogical experience of an academic student. So some words about the two types of biosensors, the pathogens detections and the technical detections. It's very, technical terms. So I'm gonna pass through very quickly immunosensors with, we have pathogens, Leishmania, SARS, aptosensors, Aereus, coli, genosensors, DNA, RNA, they detect human serum samples, saliva, etc. With many techniques, such as the interferometric biosensors with many waves, photonic biosensors, electrochemical biosensors with potentiometric, amperometric, etc., piezoelectric biosensors, which detect the bacteria on the sensor surface, and the optical biosensors with electromagnetic radiation. So we see that they use many techniques for the detection of these particles. So there are many advantages of the use of biosensors: quick analysis, great sensitivity, selectivity of many targets, reproducibility, response time, distinguish between different pathogens, and conditions requiring continuous monitoring. But there are also limits due to increased cost, specialized equipment, of course, great management of great sample volume, and increase the possibility of contamination and human error, of course. So some words about the research today and the models, the simulation models that are used today, such as the agent-based model, the system dynamics, the discrete event simulation, the hybrid simulation models that are used today mainly for 2D and 3D comparison by charts, 2D linear simulation. So our research methodology it's contain four main methodological steps, which are the biosensor implementation and measurements of nosocomial infection parameters, the geometry modeling, the simulation techniques, and of course the spatial 3D representation in VR AR environment. Some words about the biosensors. What is a biosensor? It's a sensor. It's a device and sensor that have a biological sensing element in order to detect a substance of interest that needs to be detected, which is the analyte. The analyte actually is the virus, and there is a physical transducer. Actually, is a converter that converts the biorecognition event into a measurement signal, and of course there is a bioreceptor and an amplifier that amplifies the signal amplification. On the other hand, we have the implementation process of network biosensors, a network of biosensors at the measurement points, converting nosocomial diseases values in the electrical signals, and acquisition systems with data loggers that they send the rates to the receiving base units, and of course, in the end, the computer allowing the storage, the processing, the analysis of the occurred values. The modeling process is not an easy process. It's a 3D complex spatial modeling methods. Actually, we want to use any 3D complex modeling procedure that is appropriate to have the results, such as in any case, it's a volumetric visualization, grid mappings, voxel, point clouds, 3D scanning, recognition, 3D GIS topology, etc. So all these complex models have to be adapted, converted in an appropriate format, very famous, such as the object format, Collada GL transmission format, and of course to be adapted in an AR platform such as Unity, Arcor, Vuforia, etc. In terms of representation, 3D representation, we have the VR simulation. So it's based directly on 3D vectors models or 360 bitmaps for this from these models, or we use real photo superposition, and we have a traditional VR environment. But on this environment, we can use on this GIS nebula interpolation simulation, we can use HTML5 or JavaScript programming elements with pop-up information, images, video, with interactive superimposed areas. And on the other hand, we have the voxel simulation with the input of geometry, the voxelization procedure, and the data storage visualization export with the availability of libraries such as the Open3D, etc. And here we use all these technologies on voxel, especially and mainly the LiDAR systems with SLAM technology that we use in robotics. And of course, two main advantages of this procedure, of this methodology, is the use of voxel to have a volumetric simulation, because almost it's impossible to simulate this kind of particles with other methods. And the implementation of these modeling methods and the complementarity, which is very complex, but very strong. On the other hand, the limitation is the complexity of the biosensors implementation, and on the other hand is the exhaustive technical requirements due to many formats, incompatibilities, resolutions, etc. So, to conclude, the infection diseases today are considered as a major global health challenge. The theoretical development of this of the proposed nosocomial infection particles spatial simulation allows an understandable and accurate 3D representation, while the current system today offer only 2D and 3D charts statistics and not an volumetric simulation. The use of these models, procedures, 3D point clouds, voxels, etc., offer an accurate particular volumetric simulation. However, there are limits due mainly in the incompatibilities of these formats. The proposed spatial simulation could facilitate the communication, this is very important, between the expert medicine expert and non-expert users, even the clients, the hospital staff, the public authorities, over a common platform, understandable with understandable results. And of course, to conclude, the biosensor chip technology progressed very dynamically, and we can imagine what will happen if all these excellent things around us today, such as the AI, machine learning, the Internet of Things, 5G network, etc., they will continue to increase the effectiveness of detection of such a system. I thank you very much for your listening.
Thank you so much.
I must stop the common share.
Are there questions?
Yes.
No, since we are running a bit out of time, sorry.
Yes.
We go straight. And the next presentation is by Damiano. Dockerized architecture for a progressive web app in Italia collocation dictionary. Condivido. Piano piano. Aspetta. Perché Chrome? Va bene Chrome. Usa Chrome. So perché te fanno così, aspetta. Ok.
Can the microphone
Is on.
okay. Don't worry. So this presentation is related to a PRIM project, a research project that aims to create a dictionary, the collocations can students to learn in a faster way Italian. Okay, a collocation is a combination of two words. Let's see, it doesn't work. Aspetta.
Ok, aspetta.
Okay. Just a collocation is a combination of at least two. For instance, a combination can be take a shower, or because this is a combination of words that doesn't needs to be understood in the syntactic way. The semantic information is different from the syntactic information that we read. Okay, and only if you understand properly a language, you can understand a combination of words. Okay, each language provide a combination of words. Okay, and when a student try to learn, for instance, English, Italian, or any other language, it is very important to also learn how the people speak in the real world. Okay, this is the project. Create a dictionary that can help the studying phase. So the target audience is composed by students, of course, but it can also be opened to other people that want to use the dictionary, because for now we are working to make it available for free on a website. Okay, and the core technology, the platform that we are developing, it's based on a progressive web app. Because if you want to deploy an application for smartphones, you need to you can move in two different ways. The first path is create a base code in Java for Android or Kotlin, if you want to work with the latest technology. Or in other case, you need to write in Objective-C or Swift for iOS. But there is another one technology that is the one that we choose, that use a JavaScript code. It's like create a web page, HTML, CSS, and JavaScript merged all together, that allow you to create a progressive web app. A progressive web can next, if you want, be exported as like a native app. If you want, you can do it. In this case, you are moving to another type of deployment that is called a hybrid app. But if you want, you can just leave it as it is. You have a progressive web app that you can open in your browser. And if you use a framework, for instance, we choose some framework that I will show you. You have also the layout, the graphical layout, that is automatically applied based on the operating system that you are using. So if you are using iOS or Android, the buttons will look good. Okay, that's it. So in the first thing is that we can have a single base. Okay, we can just write one code that write once to to run everywhere. Okay, the philosophy of Java that we saw in the 90s, and we can take the same philosophies today. And next, we can bypass the optional App Store and the Play Store approval process that can reject or approve your app, because you need to stay focused on the policies and respect the guidelines of the store. And also you need to pay the fee, because if you are an Android, okay, you just need to pay 25 euros for the license that is a lifetime license. But if you want to go on iOS, you need to pay yearly. Each year, you need to pay the license if you want to publish on Android. Okay, so there is also some cost that you need to take into account. And you are free to do what you need to do. This is for the base code. For the infrastructure that runs the backend, we choose a Docker infrastructure. We build a Docker infrastructure that provide a set of containers. Okay, we created some containers that allow you to separate processes in order to achieve high performance, because if you compare a Docker container with a virtual machine, you will see that Docker doesn't provide you an overhead, a very high overhead. A virtual machine reduces the performance on at least the 5%. Okay, with Docker, you are just on another namespace, so the performance are very good, and the most important part is that allow you to implement a scalability. Okay, you can create a set of Docker containers, and if you want, you can add a load balancer in order to balance in round robin the connections to all the containers that are running your web application. In this case, you can make, if you want, an horizontal scalability in order to increase the computational power of the infrastructure. And you can do it on because in a private cloud, this is doesn't have so much sense, because in the public cloud, for instance, AWS, Google Cloud Platform, Microsoft Azure, and so on, you use a business model that is the one that pay as you go. So much you are using the system, so much you pay. So, and with the unlimited, for instance, a limited number of CPUs that they can provide to you, you can increase the computational power as much as you need. And with Docker, you can add more containers that in round robin that serve users. Okay, this is the chosen system. Okay. Okay. This is an image that allow you to see the dictionary. In the left, we can see the web page. The student can just digit the word that he needs to search, and they can press search. And the next, the results will arrive. If you click on one of the results, you can have more informations. And we are adding more contents to the platform. This is just the front end. We have also a back end, front end for the users, back end for managing the data, and for the staff that is working on this. And this is a website. Okay, a website that is a progressive website that open up in full screen and allow you to use it as a mobile app. The infrastructure is the following. As you can see in the picture, we have divided the infrastructure in two parts. One for the development phase and one for the production. On the right, we can see users that access the infrastructure through a public gateway that is managed by AWS in our case. And the gateway also implement an web application firewall that is a firewall at levels that runs at level 7 on the ICCSA stack, okay, and allow you to check if the connection are trying to produce an SQL injection, for instance, because they the WAF, the web application firewall, analyze the connection, and it's very different from a firewall at level 7, at level 4, okay, that just check IP port and the protocol. Okay, and next we have a load balancer that split up the connections between a set of Dockers containers A1, AN that runs an Apache web server, and the load balancer the connections in round robin, and there is a set of codes that analyze the number of connections for instance, in 5 minutes. And if they are over a threshold, we add containers. In this way, we can add nodes, okay, in order to maintain the system stable. And if the number of connections is below a threshold, we can remove elements in order to reduce the cost. Okay, and also the same task can be done for the database. In fact, as you can see, we studied an infrastructure with 2 databases. That is the same, but it's a cluster of database. The first node is the primary node, the writer, and that can write and read data. And then we can add a set of readers, okay? Because as you know, in a cluster of databases, it is important to have just only one reader, only one writer, if you use a relational database, in order to maintain consistency. But you can add so many readers, okay? You can add all the readers that you like. And also for the database, we can add an horizontal scalability, okay? Also for this one. We separate the infrastructure for the development, the deployment phase, because we want to work in a separated system that use a different technology. The technologies that we use is composed by a Vite web server. Vite is like Apache. It's like an ultra lightweight Apache that allow you to instantly refresh the web pages when you change the code. It's so cool because you work on the code, you change the things that you like, you press Ctrl S, you are saving, and the web page in all the devices that are connected to the web page automatically refresh the page, showing the updated content. It's very nice because you can work in an ultra fast way. You don't need to restart, to reconfigure. You don't need to do anything. Just Ctrl S in the development software that you are using, and all the devices connected will be automatically refreshed. And you connect on a web browser. All the devices are every time connected using just the web browser. That's all. Vite is connected to a Node.js because Node.js it is important for the framework that we are using. For instance, we use a framework that is called the Ionic. Ionic allow you to change the style of the web page based on the operating system that you are using. If you use Android, Windows, iOS, the layout, the style, the graphics adapt automatically. With Android, the material, with iOS, the newest version, the glasses, ultra cool CSS will automatically apply. And this is Ionic, that it's completely open source. It's all based on open source software. Okay, we are only using open source software. We didn't use any software that is closed source. This is very important for our team because we think that the open source is the core component of the computer science community, and we work only in this way. And obviously, this environment must be connected to a database, a separated database that allow us to do our hacking things in order to solve problems and program the environment. And we manage all the infrastructure with a VPN in order to guarantee security. The database is managed with a PHP MyAdmin web interface, a very standard tool that allows you to connect to a database and work with the data, with the raw data, okay, that you have in your environment. This is just a table that allow you to see the dictionary, a little portion of the dictionary. For instance, as you can see, there are some collocations like fare figura, prossima volta, bene culturale, and so on. Those are collocations in Italian. And at the right, you can see some statistics that we calculate using some statistical analysis and artificial intelligence. The statistics are fundamental because allow you to understand how much one collocation is frequent in the common speech dialogues. Okay, because if a collocation is so common, okay, probably you must learn this collocation. If a collocation is not so common, probably it's an hard collocation. It's a collocation, for instance, that can be classified as C2, okay, because only native speakers use it, okay. If a collocation is used so commonly, probably it's at A2 as difficult, okay. So that's the goal. The goal is, can we analyze the statistics and create a new column in order to create to describe the difficulty of each collocation? This is a work that we are doing. It's a future work, okay. As future work, we want to define the difficulty of each collocation. As I described it to you, the isolated development allow you to separate production and test environment. This also is because you need to secure the data, and in order to access to the environment, we use a VPN. Okay, we can move faster on this part, because I described to you verbally the image. This slide's just describing using the text what I described to you from the image. So at the end, we saw that in our point of view, in order to create a scalable architecture, it's fundamental to separate the services in and the platform that we choose is Docker. Docker is also open source and allow us to create a development environment, a production environment, all managed with horizontal scalability. And it's very important for the improvement regarding the security and in the fast execution of the code. In this image, you can see the set of document that composed the dictionary. We taken into account a set of news reports, editorials, school essay, blog posts, conference, political speech, and TV series. Those are the documents that contain the phrases that contain guys that speech or just text. Okay, and this is called the corpus. A corpus is a data set of documents. And here you can see also some histograms that describe you the accuracy in the recognition of the real collocation from another data set created by linguistics, okay, that analyze a subset of the corpus manually, because we are also trying to create an AI, okay, that we call hybrid method, that use a syntactic dependency based, that is at the output of an LLP software that is spacey, and a P-based approach that analyze that produce a grammatical analysis, okay? And we want to merge those things together with a Python code, and we already did that, okay? Creating an hybrid method that is this one that combines the best qualities of the two methods in order to create the collocations. So in the slides, I show you the accuracies and the sets used to create the data sets. And finally, we are also able to create reports on the data usage of the infrastructure that runs the dictionary. Okay, for instance, we are able to plot the number of connection and the number of queries per second in order to guarantee that the software runs smoothly for the students. This is just, for now, a production environment, and we want to end this and put it online as soon as possible for students in Italy and all around the world that wants to study the Italian language. Thank you.
Are there questions? Please.
Yes, I have one. First of all, congratulations on the presentation. There was something that you mentioned that caught my attention regarding you have different solutions on your development environment versus on your production environment. Like for instance, on production you have Apache, and on development you have like PHP, Miami, I think.
Yeah, I have a Vite server plus a Node.js server. Yes.
Yes. I've struggled in the past sometimes with production environments that were different from the development environment, and I've seen some folks using stuff like staging environments or like Canary, which is a set of the production consumers that you have. Do you have something in mind about this? Or
I can explain this better because I understand that if you saw two different servers, it should be strange, you know.
Like you can have a bash.
Yes, but the solution is very easy because Node is a server that needs you to install the libraries that you want to use. npm install and the libraries that you like to use. Okay, this is slow. You can compile the code and you will obtain just a page, a real single page with a JavaScript integrated in the page that is compressed, like a compilation, at least the first steps of the compilation. So you don't have anymore a set of 100 libraries that needs to be loaded. Okay, so we extract, we compile from the node the page, the progressive web app page, because it's a single web page application. And this page can be irrogated using Apache that is ultra lightweight. And you can remove all the slow part of Node plus Vite. And the production can run only in Apache because it's plain HTML plus an ultra compressed JavaScript. That's why we use this type. Okay.
Thank you. So it's time to move to the last presentation. Denisa Borges, Marcelo Enriquez, Luis Diaz, Ricardo Machado. Creation of key processes for production systems optimization. Denisa, I guess. Denisa? Okay. Thank you. We cannot hear you. Oh, sorry.
Can you hear me?
I mute my... Sorry. Yes. Very well. Thank you.
Can you see my screen?
Vuoi riaprire tu? Yes, we see your screen. Thank you. Okay, good. Excellent.
Hi everyone, and thank you for being here. My name is Denisa, and I'm currently in the second. My name is Nisa, and I'm currently in the second year of the doctoral program in Industrial and System Engineering at the University of Minho, Guimarães, Portugal. Today, I will be presenting the paper entitled Characterization of Key Process for Production System Optimization. These are the authors responsible for the preparation of the article. This presentation covers the following points: the motivation behind the research development, the research question and the objectives that guided the work, the main process that make up the production system, a critical reflection on the research approach, and perspectives for future work. This research was motivated by the growing complexity of production system and the need for more efficient management aligned with current demands. Although concepts like lean manufacturing, just-in-time, and mass production are well established, their integrated application in modern organization remains challenging. The study aims to comply and update the main production system process, such as production planning and control, industrial process, logistics, quality maintenance, and sustainability, offering a holistic and accessible view, especially for a new professional and researchers. It seeks to both synthesize existing knowledge and generate insights for innovation and continuous improvement. This research addresses two key questions. What are the existing types of production system? What are the main processes within this system? To answer them, two objectives were set: analyze the types of production system, investigate core processes such as planning, logistics, quality, maintenance, and sustainability. Both objectives were pursued using a literature review, ensuring a structured and a comprehensive exploration of the topic. Production planning and control is responsible for planning and controlling what, how much, and when to produce it based on forecasts, orders, and inventory. Its goals include minimizing downtime, reducing inventory, improving quality, and avoiding bottlenecks. Tools such as aggregated production planning assist a medium-term production planning, while demand forecasting guides decision based on past partners. The bill of materials is used to anticipate material requirements. MRP manages materials to ensure availability when needed. MRP2 extended MRP by including resource planning and integrating costs and capacity. ERP integrates all organization areas, supporting global management and optimizing process. With Industry 4.0, production planning and control involves with technologies like a digital twin, allowing real-time simulation and more autonomous, efficient, and sustainable system. Industrial processes are sets of physical or chemical actions that transform materials, adding value to the final product. They are divided into three phases: material preparation, transformation, and finishing. There are two main types of operations. Processing operation alter the shape, properties, or appearance of materials using energy, e.g. casting, machining, and painting. Assemble operation join two or more parts either permanently, e.g. welding, and dismountables, e.g. screws. This process follow defined sequences aiming for efficiency, waste reduction, and final product quality. Transportation. Transportation is a physical link that connects materials, products, customers, and suppliers, and can be short or long distance. Transportation costs are significant, distinguishing between marginal costs, costs of transporting one additional unit, and average cost, total cost divided by the units transported. Inventory management is essential to ensure adequate customer service level and support production, especially when there are delays in purchasing or manufacturing. The transportation method influence inventory size, and perishable materials require specific strategies such as the first experience, first out, method to avoid waste. In production, quality means meeting customer needs, ensuring compliance, and delivering volume. According to ISO, it's defined by characteristics that satisfy explicit or implicit requirements. Quality management uses inspections and statistical tools to monitor process, reduce variation, and improve efficiency. The ISO 9001 and 2015 standard emphasize principles link customer focus, leadership, process approach, and continuous improvement. When integrated with technologies, this practice enhances product quality, organization maturity, and supply chain reliability. Maintenance is fundamental in several sectors, especially manufacturing, where it directly impacts product quality, asset value, and organizational success. Traditionally view in isolation today, its integration with other areas and the supply chain. Essential. There are three main types of maintenance. Corrective maintenance performed after failures requiring diagnosis and human intervention to fix problems causing unplanned downtime. With more complex system and Industry 4.0 technologies, training is increasingly important to avoid errors. Preventive maintenance, scheduled at fixed intervals to reduce failures and avoid unexpected downtime, usually performed outside production hours. Predictive maintenance uses a real-time data to anticipate failures and repairs, optimizing resource and costs. It requires investment in advanced technologies such as sensors and the digital twin, helping to prevent severe damage and operation risks. Sustainability is about maintaining and balanced relationship between people and nature, ensuring resource availability to current and future generation, guided by ESG framework, environment, social, and governance. It promotes responsible organizational practice. Originating from green manufacturing, sustainability focuses on reduced pollution and waste while using renewable energy. It also emphasizes continuous process improvement, responsible resource use, adoption of clean technologies like solar and wind, and addressing social aspects such as job creation. Production systems are complex and must align with organization strategies to ensure performance. Staying competitive requires adapting to market change and embracing innovation. This study presents an integrated view of key process and concepts enabling collaboration with fields like simulation, machine learning, and data engineering. By linking fundamental simulation elements, e.g. source, server, combiner, or separator, the research supports system optimizing and lays the foundation for future advances, especially in using simulation as a decision-making tool. These are the acknowledgements. Thank you for your attention. Any questions?
Yes, thank you. I was muted because of. Thank you so much for your presentation. Any question from the audience? Okay, no questions. Thank you so much. And we closed the session a few minutes in advance, but thank you. Thank you for attending the event. Bye-bye.
Thank you.
Thank you. Thank you for all.
Thank you so much. Okay, we close the session.
Prova. Okay, ladies and gentlemen, we can start the presentation of this first speaker of today. So, the title is Fast Agent-Based Solution to Evaluate the Matching of Public Transport Offer versus Citizen Mobility Demand. And the floor is completely yours.
Hi, I am Luciano Alessandro from Florence University, and my work is about a fast agent-based solution to evaluate the matching of public transport offer versus citizen mobility demand.
Okay. Yes. Don't move it. Don't move it. No, don't move. Just don't move it. Oh, okay.
Okay.
Exactly. Okay. Please. Okay. Very nice. Sorry.
Public transportation is fundamental for sustainability in smart city and free mobility in smart city. It's an important topic. Yet matching transportation supply with citizen demand present significant computational challenge. The first challenge is the height complexity, because in big cities simulating millions of entities, people, vehicles, stops, with complex multimodal routing required substantial computational resources. Another challenge is the real time. What if analysis is important? What if analysis scenarios demand rapid computation times to support practical decision making? And optimization need. City need the tool to minimize the gap between transport offer and mobility demand while optimizing cost. For example, in validating in Florence City, the scale of simulation in one day, there is 150,000 people, 8,000 vehicles, and 3,000 stops. In the context of smart city digital twin for data-driven urban mobility, the first thing is the data source. Need static data, for example, the road network, the public transport routes, the historic data, the travel demand patterns, and the congestion in the road, and real-time data by IoT sensor, GPS trace from the buses and vehicle flow. For decision support, it's important to enable automatic optimization, provide actionable recommendations, and support urban stakeholder decisions. The data-driven insight is important for evaluated demand responsive transport system, support fact-based urban planning, and detect inefficiency and predict demand. And the last is the digital twin simulation, simulated infrastructure and service change, perform what-if analysis, and model complex urban interactions. Agent-based modeling simulates complexity in social system by modeling each participant as an autonomous entity with decision-making capabilities in the simulation. In transportation context, agent-based modeling effectively models the interaction between mobility data, the citizen, and transportation offer, the service and infrastructure. The key challenge in the work is creating a realistic scenario require significant technical expertise. Computation demand increase exponentially with simulation scale. Balancing detail and performance require careful optimization. In the state of the art, there are two types of approach. The first approach is with analysis in the city. The key performance indicators are height level indicators. Was fast for computation. There are less detailed for representation of reality. And the other type is the agent-based models. Faithful reproduction of reality, high detail and granularity, higher computation cost, and complex configuration. But is more realistic interaction about the agent. And the common limitation in the state of the art is the limited accessibility. Many tools require specialized expertise. Narrow scope, often focused on specific aspect rather than holistic view. Time consuming for setup, for example, the velocity for the bus, the velocity for the pedestrian, etc. Step learning curve, barriers to adoption by stakeholders, and high computational demand, restrict scale and scenario testing. The requirement to satisfy good fast agent model, we have two types of requirements. For simulation and data input, the operator need for area selection, timestamp selection from hours to multi-day simulation, public transportation offer input compatible with GTFS, route, stop, timetable, and capacity for the bus. Multimodal support, because in the city now there are buses, trams, trains, and sharing options for bike or car. And the demand input usually support original destination matrix or other type for demand input. For execution output capability, it's important multimodal routing. We use Grasshopper and OpenStreetMap for efficient trajectory generation. What's important, the scalable performance, efficient for large scale and long-term simulation. Vehicle tracking, location and occupancy for each vehicle service in time. The KPI for the stop, waiting, boarding in the stop, occupancy at each stop, etc. And key performance indicator generation for pedestrian, for the bus, the height level key performance indicators. Our proposed agent-based solution is a novel open source approach. Designed to match transportation offer with citizen demand, addressing key limitation of existing tool. First, reduce the computational cost. Is multi-thread. There is a minimal setup required. Use only as input. Use only the GTFS, the original destination matrix, and the city road graph, for example, in OpenStreetMap. Is scalable to large scenario for big city and multi-day simulation. And is what if ready. Timely simulation, deliver actionable insight quickly without sacrificing accuracy. and comprehensive key performance indicator for the operator or the decisor in the city. Is developed within Snapper City framework. Is a big and complex infrastructure for data ingestion to perform analytics and artificial intelligence framework in the data. The step was the setup of parameter, the area, the timestamp, the offer, and the demand. The data pre-processing, the GTF transform the GTFS in JSON for a bus, and filtering the demand by area and time the operator chooses. After start the routing engine, Grasshopper, OpenStreetMap, and GTFS. Is multimodal trajectory computation, sharing, bus, train, other type. And after start simulation and analysis. Is scalable because use of zone centroid for faster routing. There are parallel Grasshopper instance for load balancing. There is a cache for the trajectory, a database cache. And runtime efficiency, for example, vehicles loaded only during their route lifespan. The instance pedestrian at the departure stop and removed upon arrival, and reduced memory footprint for large scenarios. There are two types of agent. The first type is the transportation vehicle. Was the active agent in the simulation, follow the GTFS timetable. The tool track position and occupancy every second. Collect waiting pedestrian in the bus stop. And after we have the passive agent, was the pedestrian in the bus stop, and follow a routing calculating by with Grasshopper. The key performance indicator output for the simulation was a meet demand, mean time and travel ratio for pedestrian, vehicle occupancy every second or minute, stop analytics, and waiting time for the pedestrian in the bus stop, and the walking time. We validated the tool in Florence, plus suburb like in Sesto Fiorentino, Scandicci, and Bagna Tripoli. The zoning was 4,624 MGRS zone, 200 for 200 meters, and the timestamp was in November 15, 2024. The input provided the input Autolinee Toscana, Jest for the tramway, and Trenitalia for the train. In totally, in the simulation, there are 7,000 buses, 800 trams, and 400 trains. And the mobility demand from team was 150,000 passengers in a day. This is the distribution in the area of the day. For original destination,
Okay.
Yes. In Snapper City, there are the data for original destination. The performance for the framework, routing work in for core, 4 graph hopper instances on separated virtual machine. The times was 1,800 seconds. The simulation of 1 day without cache was 2,700 seconds, and with for 1 day. Using cache, we perform 10%. The second was 271. This is the key performance indicator for the simulation. The plot for the bus stop, how many people board and drop in the hour in this or other bus stop. And we try the what if analysis because it is the scope of the goal for the work. For example, when there is in a bus line many people waiting in a bus stop, we try to add other line and have this result.
Okay.
This is a conclusion, and thanks. The time.
Thank you. Thank you. If there are any questions, you can proceed. Okay, no question. Thank you.
Thank you.
So now we can move to the second presenter of today. Let's open up the Jitsi room. Okay, the second paper is real-time rigging and secondary motion for sketch-based 3D characters, and the authors are Cho Mati and Tam Min Lee. The presenter is Tam Min Lee. So, can you hear me? If yes, we can try the audio, and then the floor is yours. Because now I cannot hear you. Can you hear me? No, maybe we have an audio problem. If you look at your output, maybe you can try to change something because we are not hearing you. Maybe. The layout of the keyboard.
Can you hear me now?
Okay, now we can hear you, so you can proceed, please. Thank you.
Okay. Okay, today I'm honored to present our research entitled Sketch-Based 3D Animation Generation at ICCSA 2025. Before we dive in, here is a quick overview of today's presentation. So for the introduction, as we know, character animation is a powerful medium for storytelling and education. However, it remains a labor-intensive process, particularly during the production phase where tasks such as modeling, rigging, and animation consume significant time and resources. And then many artists, educators, and especially beginners, they often struggle with the complexity of 3D pipelines such as Blender or Maya before they can bring animation in their idea to life. So because of that, our goal in this work is modest. We are attempting to reduce this workflow to allow anyone, regardless of their technical background or artist background, they can access animation even if the result is still very simple and far from perfect. So to provide some context, let us briefly review existing research and methods that have laid the groundwork for this area. Firstly, sketch-based modeling has been explored extensively to simplify 3D content creation. Instead of requiring artists to work with complex 3D interfaces like Blender, sketch-based modeling allows users to draw 2D shapes, which are then converted automatically into 3D models. And this significantly lowers the entry barrier for beginners while also supporting rapid addition for advanced users. And secondly, rigging. It is a critical but tedious step in the animation pipeline, involving the creation of skeletons that enable models to move. Existing work such as RigMesh, RigNet, and RealScale have advanced the automation of skeleton generation directly from sketches, reducing manual rigging tasks. And in addition, mass spring systems have been widely applied to simulate soft body dynamics, including hair, cloth, and other deformable objects, leveraging springs and masses to generate realistic secondary motion. However, traditional methods for implementing mass spring systems often come with a significant computational cost. They can be slow to converge and unstable, especially when we need real-time responsiveness for interactive animation. As you can see on the slide, calculating ease is a nonlinear problem, so that leads to a lot of calculation problem. So the key idea of the paper, we adapted the paper Fast Simulation of Mass Spring System in SIGGRAPH Asia 2013. The key idea is to split the simulation into local steps where springs are individually projected onto constraints and global steps where a single quadratic problem is solved efficiently to update positions. So this framework enables real-time simulation while preserving the elastic behavior of objects, making it well-suited for interactive applications like ours. So in more detail, the fast mass spring system reformulates the nonlinear energy minimization problem by introducing auxiliary variables during the local steps, which represents the projected positions of mass points. It allows the global step to solve a symmetric positive definite system, enabling fast and stable updates. By adopting this framework, we can efficiently simulate simple secondary motion in our pipeline without requiring heavy computation, aligning with our goal of maintaining accessibility while providing dynamic animation effects. So building on these three foundations, our contribution integrate this concept to develop a sketch to animation pipeline that firstly instantly generates 3D models and skeletons from sketches. After that, the system will automatically add real-time secondary motion through spring dynamics. And finally, it can maintain simplicity without sacrificing artistic control. So we aim to reduce the workflow so that everyone, even novice or people with no experience with animation, can access the field of animation, although the result is still simple, as you can see. So now I would like to walk you through the methodology that we propose in this paper. So on this slide, we can see that there's a side-by-side comparison between the original RealScale framework that we adopt on the left and our modified pipeline on the right. The left diagram illustrates RealScale, which takes a hand-drawn 2D seal holder, performs automatic skeleton extraction, and then generates the 3D shape, support real-time rigid animation using methods from old research like Teddy in 1999. And on the right, we build upon this real scale framework by adding a key component, the fast mass spring system, which is highlighted in pink from Liu et al. In SIGGRAPH. So by integrating this mass spring system directly into the skeleton level, we aim to enable dynamic secondary motion in the generated 3D models, moving from rigid animation to simpler and dynamic animation while retaining real-time performance. So from the user's perspective, the workflow is kind of straightforward. Firstly, the user sketches the desired character, and then the system will automatically generate the 3D model along with its skeleton. The user can now directly animate the character with secondary motion effects without needing to handle rigging or physics manually. So at the core of our dynamic system is a mass spring optimization framework. As we know from the original paper, Fast Mass Spring System, this framework keeps the rest length of each spring fixed, and we only need to optimize the positions of the mass points to minimize the system energy. To efficiently solve this in real time, we adopt the three-step iterative method: local update, global update, and convergence check. In the first step, local update, given the current positions of all mass points, we compute direction vectors for each spring. These vectors represent the forces acting with the system, preparing the necessary local constraints for the subsequent update. Next, in the global update step, we utilize the computed vectors to update the positions of mass points by minimizing a quadratic energy function. Because the system here is symmetric and positive definite, as proved in the original paper, it can be efficiently solved using Kolesky decomposition, allowing stable and rapid computation even during interactive animation like in our workflow. And finally, in the convergence check step, we assess whether the system has achieved a stable state. If it has not converged, we will repeat the local and global updates iteratively until convergence or until a maximum number of iterations is reached. So it is important to note that since the system operates on the skeleton structures rather than dense meshes, the computation is very lightweight. Moving on to our results and discussion part, we tested the system on some models to evaluate its effectiveness. So without secondary animation, the motion often appear rigid and mechanical. However, with our system, animations become more expressive and smooth, as if it is made from some deformable objects. And we also examined the impact of stiffness parameter K. At very low values, the system can become unstable. At medium values, it achieves balanced and elastic motion. So this is the value that we recommend for our system. And at high value, it becomes slow. The motion becomes overly damped, and it is barely see the dynamic. The dynamic is barely see. In terms of computational complexity, the local update runs in ON, and the global update requires n to the number of 3 due to Kolesky decomposition, but remains feasible since skeletons typically have less than 20 nodes or 30 nodes. So while our system can perform and achieve results, we identify some limitation. The automatic PBW algorithm can lead to uneven weight distribution, and there is limited manual control for users to adjust weight or skeletons. And the absence of shear and bending springs currently limits advanced soft body effect. So to summarize, in this research, we have developed a sketch-based 3D modeling and animation system that combines real-time skeleton generation with a fast mass spring system to enable secondary motion. This work enables animators and educators to quickly bring characters to life without requiring advanced technical skills. So in the future, to address the limitations, we aim to improve weight distribution for smoother deformations and integrate shear and bending springs for more realistic soft body dynamics. Also to automate continuous secondary motion without additional user input and optimize performance for more complex and detailed models. So that's for my presentation. Thanks for listening. Thank you for
Thank
listening.
you. Thank you so much. Thank you so much for your presentation. There are any questions? No question from here. So thank you so much. Now I want to ask the next presenter to share the screen. The paper title is Hierarchical Sort-Based Parallel Interest Matching Algorithm for Distributed Simulations. The authors are Martin and Tim. So, okay, can you hear me, Tim?
Yes, I can hear you.
Mr. Tim. Okay, so please, you can. The floor is yours, so you can start your presentation. Thank you.
Is my audio clear? Okay, can you hear me clear?
Yes, perfect. You can proceed. Thank you.
Hi, my name is Tik, and today I will be present to you on our work uh, of hierarchical sort-based parallel interest matching algorithm for distributed simulation. So distributed simulation or distributed virtual environment are shared virtual space allowing multiple geographically dispersed users to interact simultaneously in real time. It underpins various interactive systems today, from multiplayer game online to collaborative virtual reality applications such as virtual classroom and museum. As distributed simulation grow in scale, efficiently managing data become essential to maintain low latency and minimize bandwidth usage. Therefore, we need interested management, a mechanism in which relevant data is selectively exchanged among entities in distributed simulation based on overlapping of two defined area of interest represent the user vision, and area of affect represent the entity presence. Traditional interest matching method, including aura-based, zone-based, and visibility-based, each have distinct strength and limitation. Zone-based method offer higher scalability than aura-based, but it suffer reduced precision due to its rigid spatial partition. Many modern solutions use hybrid method, leveraging the strength of both scalability and precision. We introduce hierarchical sort-based parallel interest matching algorithm, a state-of-the-art interest matching algorithm based on hybrid scheme. It represents area of effect and area of interest as axis align bounding box in space. These bounding boxes are mapped and sorted into corresponding container of node in binary dimensional partitioning tree, a core component data structure that use binary tree on each dimension. There are two variants of our method, static and dynamic. Both have two main steps, mapping and matching. The static variant recalculate all overlapping results. every time the procedure is called. In contrast, the dynamic variant only recompute the match for modified reason, but it introduces additional steps to preserve previous result. Our method, uh, leveraging the hierarchy of binary dimensional partitioning and sort feature, offers some key advantage. It efficiently identifies overlap by checking membership and neighborhood relationship. It minimizes unnecessary iterating and comparison operation, and matching between sheets is parallelizable due to partitioning structure. We evaluate overall runtime to assess its practicality by measuring each step on both static and dynamic version. And we found dynamic mapping outperform static mapping when fewer 15% of entity undergo change, indicating its efficiency in low change scenario. In the matching step, dynamic matching show mixed result, while it beneficial in specific case. Its inefficiency in result recalculation step make dynamic matching undermine static matching overall. In conclusion, static matching outperform dynamic matching in general, contradicting the original author claim that dynamic is superior. This is because their assessment on focus only on the matching step, not the full pipeline. We also enhance the original algorithm by eliminating redundant steps and fixing algorithmic logic to improve its correctness.
Okay, we
And
can. Okay. Can you hear us? The network
yes,
quality probably is poor, so please continue. Yes, thank you.
and practical application within Unity job system can handle up to 2,000 entities in real time, making it suitable for large-scale distributed simulation. And that concludes my presentation. Thank you for listening.
Thank you so much for your presentation. There are any questions? Okay, it seems that there are no questions, so thank you again. The next presentation is with the title A Strategy Utilizing MLLM and Augmented Reality for Handling the Missing Data, a case study using Unity, Vuforia, and ChatGPT. I now will share the presentation and give you the floor. This one is the file, I think. Can you take a look? This one is yours?
No,
Rui Just?
it's called Diego presentation.
Agent Visit, this one? No.
Diego presentation. Was in the pen drive.
I didn't copy the file. Okay, just a moment. Just a moment. I was thinking that we copied.
Yes.
Agent Visit, this one?
This one.
Yeah, this.
Just copy the link.
Yeah, we
Because
can.
I tried to use the pen drive and it had some problems.
Yes, absolutely. Don't worry. Just a moment. I will. I need to share the screen. Okay. So the presenter is Diego Diaz. So the floor is yours.
Good afternoon. I'm Diego Diaz, professor at Federal University of Espírito Santo in Brazil. And I'm going to present the paper from Enio Limas. He was a master's student in Brazil. on University of Campo Limpo. He was advised by Professor Marcelo Guimarães, and then was his co-advisor. He could not be here, so I'm going to present the paper for the student. So missing data is a pervasive problem in data analysis, presenting virtually all domains, from healthcare to business and scientific research. It's a problem for everyone. Incomplete data sets compromise the reliability, accuracy, and validity of statistical analysis and machine learning models. Everybody is working with data and machine learning, so missing data is really a problem for everyone. So traditional approach to handle missing data often require technical expertise. So you need to know about the development. You need to know about the deep statistical knowledge. So what kind of imputation data you need to use to figure out to imputate the data, the missing data. Sometimes you need the manual coding on complex software tools to analyze the data. In this paper, we propose an innovative approach that combines two emerging technologies, large language models, LLMs, for automating analysis and code generation. So we read the data sets, we figure out the missing data, then use the LLM to generate data. And we use the augmented reality for immersive and interactive data visualization. So we use AI to visualize, to give some cognitive visualization to see what is missing, and so use the LLM to imputate the data. So the motivation for our task, poor decision in process can lead to biased results, not good results, poor models in machine learning, loss of valuable information, and invalid statistical conclusions. So the key challenges when dealing with the missing data are understanding whether the missing is handled or systematically. We need to understand this to try to figure out what kind of what technique you're going to use to input the data. Selecting proper imputation strategies based on the dataset structure and type of business, so categorical data, numeric data. Communication and visualizing data quality, both technical and non-technical audience. So our approach, in traditional methods, we rely problems like statistics, reports, and 2D plots and print sets. And these tools are limited, especially for large and complex data sets. The motivations in our paper was to create an intuitive, visual, interactive solution, combining augmented reality, virtual reality, for immersive visualization, with AI-driven assistant using an LLM model to support analysis and decision making. This approach aims to make missing data handling more efficient, understandable, and accessible. So the objectives, we have the main one that was to propose and validate a strategy that integrates LLMs and AI to assist in analysis and treatment of missing data. And some specific objectives, like enable users to visually explore using cognitive visualizations, leverage LLM to generate SQL queries and analysis scripts. So we use the AI to read the data set, understand what's there, the kind of data, what is missing, and generate the inputted method. Then we use the AI, the AR, to visualize all of them. Then we provide an interactive process where users can analyze the data using virtual reality and augmented reality, apply the treatment, use LLM, and reevaluate it using again the virtual reality application. So you see, you check, you choose your application data, use a specialist system based on LLM, and after you can check again and see if the missing data was solved. And make the process accessible even to users with limited programming or statistical expertise. That's what you can have with LLM to support this specialist system that supports all the process. So the central challenge was how to make the process of analyzing and treating missing data more accessible, efficient, and less dependent on advanced technical expertise. So as I said, we have problems like problems with random and systematic data missing. We have to select appropriate imputation methods in challenging, simple methods being insufficient and complex ones can require deep learning understanding. So you can have some simple statistical approach, or you can have some deep learning approach, for example. Incorrect imputation can lead to new problems such as overfitting. So it's a problem. also. In the proposed solution, we used augmented reality for immersive 3D visualizations to help to identify, locate, and measure missing data patterns effectively. Yeah, as I said, we use the AI to assist it with the code generation for visualizations, to SQL query to get the data from data set, to support data analysis and recommend or generate custom imputation methods. So if you cannot solve with statistical methods, you can use LLM to generate code to try to input the data using some more accurate approach. This combined approach aims to facilitate exploring data analysis and streamline the selection of appropriate handling methods. So we want to provide research for exploratory data analysis, facilitating the selection of methods handling missing data. And our approach consists of two cycles, with two main sub-cycles. First one, the data analysis, that focus provide visualizations through 3D charts using augmented reality. You assess, you locate, you measure the missing data. After you find the data, what is missing, you can use the data treatment that aims to manipulate data through the selection of methods for handling missing data. For example, record elimination, when you cannot input the data, you just put off the example, the line from the table, for example. Use the mean values, use some regression, you can see everything using AR review. You can choose what kind of imputation method you're going to use. And the strategy ensures the cycle is restarted and executed until the user is satisfied. So you can visualize it, you can visualize again, you can use some different chart, for example, bar, pie chart, and after that you can handle with the AI. So the LLM, it generates source code for the chart. So this chart, the kind of chart generated in Python code, uses LLM as an assistant. Extract information from the database. So the queries are created using the LLM. Develop methods for handling missing data. So mean values, regression, everything is doing using Python code. In providing quick information necessary related to missing data, encoding, and race analysis productively. The augmented reality, as I said, helped us to understand the missing data through the charts and help us to check again after they put the data if everything is okay. So here the starter flow that I already mentioned before. The camera for the AR markers associated with charter. You have a AR marker for the data, another one to choose the query I want to do. Use an LLM to create a new 3D chart. Excellent. Then did the visualization, I have a question. Did the visualization provide a satisfactory understanding? No. I can do everything again, trying to understand what's happening with the data. When I'm satisfied with the understanding, I can go to another part, the second part of the cycle. That is the data treatment, where I'm going to use the LLM. And after that, I can check again using AI. So we developed the MDT-AR, missing data treatment, with the help of augmented reality to illustrate the implementation of the strategy. It was created using Unity, so Unity IDE, the motor engine, with Vuforia for augmented reality, and ChatGPT for queries, to create the code for us, the code for charts, code for imputation methods, and everything. We use a data set with only 1,000 records and with 8 columns, and 6 columns were categorical and 2 of them were numerical. So we have 8 input variables. 2 main models: analysis, visualizing, and treatment with LLM. Here we have an example what you can do using augmented reality. So you can see here the yes, each bar represents a column in data set. Of course, it's there. And the height indicates the number of missing values. So you have 917 are the values, okay? And here you have the missed values for each one of the tables. And the user, he can rotate and explore the missing patterns for different perspectives, and it helps to identify which variables are most affected by the missing data. Here we have some examples of the data missing for team, for name, and this was the data set we used in our case study. Several columns have missing values. This is just a part of the data set, of course. And here, the data treatment. As I said, you can choose the data treatment using augmented reality view. So you have mode, mean, median, box plot, linear regression, some basic imputation methods. But as I said, you can use ChatGPT to create another ones. So nothing is automatically. You need to do manual. It's like a specialist system to help you to mitigate the problem of this data. So yes, I said before. After the data treatment, you can see we figure out the fields where we're missing it, and services, the name. And this figure shows the dataset after missing data. Previous missing values have been inputted using the select methods. Green lights, white lights indicates that all missing data points were successfully addressed. And this step verifies that the treatment was effective before processing for further analysis. Here we have the post-treatment visualization. As I said, you check with AI, we input some data, and after you can check again using augmented reality. So here you can see all the data is here. We don't have listen data anymore. The results. We needed 12 interactions with ChatGPT. So since the beginning, what kind? Let's create the SQL. Create the SQL. Choose bring the data. Now plot a graph for me. Bar plot. So generate the graph again. Work 12 interactions until you have the result at the end. And with useful data treatment, after applying the strategy, the dataset achieves 0 missing values, indicating successful data processing. In the post-treatment verification, visualizations confirm the effectiveness of the process, showing that the data was restored. The ChatGPT accelerates the process. You don't need to try to figure out and looking for solutions on web, for example. You can use it as your assistant. Then code adjustment needed. All the code that was generated by ChatGPT needed to be made some configurations there. They didn't run out of the box. Of course, we have some limitations. The performance degradation occurs with large data sets. It's a problem. Actually, for LLM to check, to carry everything, and to verify, to visualize if AI is also a problem, because you can have a lot of variables. So maybe you need to make a pre-process, choose only the most valuable variables for your model. And the system still requires users with specific technical expertise, AI application development skills. You need to know how to use Vuforia, use Unity. Expertise in dataset manipulations, experience interactions with LLMs. I think now everybody has this experience. Everybody uses LLM for some purpose. And knowledge of handling missing data. The code generated by ChatGPT, while helpful, consistently required manual adjustment before effective use. The current version lacks features for comparing different treatment methods, and there is an absence of precise graphic control. As conclusion, we propose a novel strategy to handle missing data, integrating LLM for analytic support and code generation, and augmented reality for visualization. This strategy was validated through MDTR, a prototype, actually, for application built with Unity, Vuforia, and ChatGPT 3.5. And MDTR, the feature based on ER, offering an intuitive and immersive visualization experience, allowing detailed understanding and manipulation of 3D data models in real-world environment. So you have some limitation in feature work. The performance degradation is something we had to check with large data volumes and the need of technology. And feature work includes adding new analytical tools and imputation methods, optimizing for larger data sets, conducting user evaluations. Here's some acknowledgements for the first CAPS from Brazil, CNPq, and FAPIS that supports our coming to Istanbul and other stuff. Here's some partnership of the research, Unifesp, where Professor Marcelo Guimarães teaches, UFIS, me and Rodolfo, Universidade Federal de São João del Rei, where I used to be a professor, CAPS, FAPS, CNPq.
Okay, thank you so much. There are some questions? Okay, I have one question for you. Do you think that you can integrate in your workflow a local LLM like Gemma, for instance, instead of using ChatGPT?
Yes, because ChatGPT is a public LLM. We're trying to use now Llama, for example. Downloading Llama and try to do some fine tuning to expertise only this kind of solutions. Read the data, create some graph, and you're gonna use Llama, for example. You're gonna use ChatGPT anymore.
And how many billions of parameters do you need? Should be enough for your work?
We are trying something with that first one with like 8 million, I think.
8 million should be fine.
Because we're using that numerical categorical data for now. I think it's gonna be great for now. Let's see. But we're trying to increase the model. But the first one's 8 million.
Okay, thank you.
Thank you.
Okay. Let me share the presentation because the last presentation is digital heritage to improve accessibility and break down architectural barriers. And I am one of the authors, so let me share the screen and the slides. Okay, the screen is already online. So the authors are Damiano Perri, Sara Martinelli, the professor Osvaldo Gervasi, David Berti, and Gilberto Zinobro. Okay. So in this work, we tried to recreate a virtual environment of a castle. Okay, we want to try to create a 3D environment that can also be used by people with, for instance, disabilities that want to view an environment, that want to view a building, and that are not able to reach and to, for instance, cross the Italy, okay, because they have some problems, or because the building itself is not with all the facilities that can accommodate a person with disabilities. This is one of the main reasons for this work. And the other one is to protect the digital heritage, because in Italy, but as you know, all around the world, there are so many structures that must be protected. We can think about earthquakes, we can think about all the type of disaster that you can imagine. And we think that if we are able to recreate a 3D environment that is accurate, but highly accurate, okay, we can preserve also for the future generations the heritage that our country can propose. So this is very important for us. And we tried to use Web 3D technologies in order to be able to explore and look at the environment using just a mobile browser, without without restricting the access to a specific operating system or to a specific closed source code. Okay, we want to try, okay, in this work to view those environments via mobile browser, and to do that of the castle using different technologies. The Bufalini Castle provides so many physical barriers, and is a castle constructed during the 50th century, and the design is not easily accessible for those who have mobility disabilities. And we try to recreate the interior of the castle using a technology that is the photogrammetry. Okay, the photogrammetry is a technology that allow you to create a 3D mesh starting from, for instance, photos. Okay, so you can take pictures of the environment, and then with an artificial intelligence software, you can recreate the mesh, the 3D mesh, but also you obtain some problems because in the majority of the case, after the first phase of the photogrammetry steps, you obtain too many vertices, too many polygons. The meshes are too complex and are not usable as it is. So you need to decimate the polygons, the vertices. So you need to reduce also the quality, but it is important in order to use the elements, okay, that you are capturing. And next, you can export the meshes in order to create a virtual environment. Okay, so we are focusing not in a mixed or augmenting, but just in virtual reality. Okay, you just need to explore using the display of your notebook. We need to capture the interior part and exterior part. For the interior part, we used a different software that I want to show you here, that is Matterport. Instead, for the exterior part of the castle, we used a LiDAR attached to a drone. Okay, so we got a drone that was able to fly all around the castle. We obtained the permission to do that from the staff of the castle. We taken so many pictures all around, so we obtained the pictures and also the light beam. And next, the interior part was only made by LiDAR, using the LiDAR of an iPhone 16 Pro, because the Pro model of the iPhone offered this capability to cast a laser beam, okay, that can be used to capture the sides of the meshes, okay, that you are framing during the steps. Obviously, the quality of the LiDAR scan of an iPhone is limited, okay, because it's a product around €1,500. Okay, there are LiDARs with a high specs, okay, with a high level of a very high quality, but they cost too much for us. So we were limited to a consumer smartphone, okay, but it is an hug for a concept, okay, a prototype that can also be expanded in future works. And the technology for the interior, as I was saying, is Matterport, that allow you to create a 3D reproduction of the rooms and the object of the inside that you can also explore in a 360-degree environment and allow you to move. It's something like, at the end of the day, like the Google Maps, that you can move, but inside a building and created by yourself, that you can also export. Okay, this is produce an output that have dimensions that are very, very accurate. Okay, the dimensions are accurate, and the scale is also accurate, so it can be used for real project. Okay, this is those are some pictures that allow you to see the what we saw with Matterport. There are some points that you can see here. As you can see, there are, for instance, in this room, the points ranging from 1 to 7. Those are like spots that you can click, and the camera will just move, for instance, in the point 1, the point 2, and you will have a 360 degree. This is just the output of the software. Okay, you can export the old interior, but you can also view a 360 photorealistic view. Okay, just moving between the spots. This is for the interior. We focus the work just on the three main rooms: the salone, that means the main hall of the castle, the Camera dei Pagani, and the Camera di Apollo. Those are the names of two of the rooms. Okay, and the software allow us to export an OBJ. Okay, you know, the OBJ can also be used in Blender if you want, or in Unity without any problem. And you can also improve the OBJ. You can modify the OBJ because it's an editable file. Okay, and also you will have a dollhouse view. A dollhouse means that you have a 3D completed environment, and you can move freely around the rooms. The accuracy, we measure the accuracy, and we detect that it was greater than 99%. Those are some of the images produced by the software. So as you can see, those are not just pictures. Those are the images obtained after the reconstruction of the interior of the castle. And as you can see, in our opinion, we obtained a photorealistic graphics of the interior. To reproduce the exterior, instead we used a completely different workflow, because we needed a drone. The drone was equipped with a camera, a popular drone, okay, DJI drone, okay, a very popular drone that allow you to adapt the bottom of the drone to the majority of the reflex that you want to use. We put a real reflex, and in order to capture the images around the castle, we needed to set up the reflex in manual mode, because you need to choose the three parameters in order to take the shot. The ISO value needs to be the same for each picture. The aperture of the lens, and the focal length. Okay, you need to select the three parameters, and the shutter if you want, you can just leave the ISO in auto. If you want, you can do it. But it is important to leave the focal length fixed. Otherwise, you probably will obtain some of the object in focus and some of the object out of focus. Okay, because you are changing the depth of field. Okay, this is very important. And we've taken at least 500, 600 pictures. Okay, some of them need to be removed because are with shadows and so on. So you need to collect a high number of pictures at different heights. So, for instance, you need to take pictures all around the castle at a fixed altitude. Next, you need to take another path of circular of images all around the castle at, for instance, 5 meters above the previous point. And next, again, also 5 meters above, all around the castle, you need to take again a set of pictures, and so on, because the photogrammetry works in this way. After that, we used a workstation of us in order to process the images. And as you can see, the drone model was the DJI Mini 3, that the one we used. And next, we process the images because we obtained also some problems with the plants, because all around the castle there are so many plants that, and the weather, if it's not windy, the plants usually moving even a little bit. Okay, and a photogrammetry software try to match the position of the objects from a picture to another picture all around the castle, and if the objects are moving objects, the object recognition will not produce accurate results. So it is important to take into account that the plants in an exterior environment are a problem. Okay, this is important. And also flying objects like birds and clouds that produce shadows. It is important to watch what you are taking during the process. Next, we create a Docker environment in order to create a production environment where we can work that is possible to move to other machine. This is just because we want to have the possibility to export the development environment. So we use a Docker that, as you know, allow you to create a separated space inside the machine called the container that contains just the tool that you need. And because it's collected inside an image, you can just pull the image and transport it into another machine. It's very easy to use. So we choose this type of tool. And this is the output of the environment. Is completely, you can move the camera all around the castle if you want. You can move freely, you can zoom in, you can zoom out. We reconstructed. As you can see, there are so many green spots all around. Those are plants. Those are grass, I think it's grass, yes, and some moving parts. But this is the work that can be exported. And if you want, you can export the OBJ model, for instance. You can import it into a project like in Vuforia, and you can have an augmented reality castle in your piece of paper. You can do it because it's completely exportable. Okay, and you can use it whenever you want. The result shown us that is it possible to use also consumer hardware to recreate environment, and we want to the scope, the aim of the work is the creation of this part of the castle, but also it is important for us to disseminate the knowledge that it is possible to protect, to recreate digitally the heritage that we have in order to share, okay, to share them to future generation. Because if we want, also with consumer hardware, we can start this process. Okay, imagine that if we create an online repository, okay, created by the community with the environment that can be accessed also in the future for future generation. An online repository with the environments that we have. As future work, we want to improve the project, integrating a virtual tour in a website accessed by a QR code or an hypertext link, and allow people to freely move into the environment, because what you saw now is the project, but it's not now publicly accessible. Okay, we didn't create right now the website for the public, but as a future work, we would like to do this. And this completes the presentation. Thank you. So if there are some questions.
We have the indoor castles, but yes, only the outdoor.
The outdoor, but also the indoor. I can show you.
Yeah, because you didn't show the indoor.
No. No. Yes. The indoor is like this one, and
you use LiDAR, right? For indoor.
for the exterior and for the interior, we use an iPhone 16 Pro with the LiDAR sensor. That is important for our project. But for the interior, the LiDAR is completely fundamental. For the exterior, we choose at the end a photogrammetry with the photos collected by the drone and the reflex attached to the.
Can you use it as a 3D environment when you use the indoor?
Yes, it can be used as a 3D environment. It can be exported as OBJ from Matterport. But it must be taken into account the complexity of the environment, because as it is, you will have so many vertices, so many polygons, and probably if you import in Unity, you will obtain a project that is that needs to you need to decimate the number of elements in order to use it on a consumer device. Okay, otherwise it's too heavy. Okay, thank you. So I think we ended the presentation, and we can close the session. Thank you.